So the word cardioid, what does that make you think of? Cardio, what does that make you think of? Oxygen. Interesting. What does that root mean? Should I ask your English teachers? What is the root cardio? Heart. Yeah, it means heart. That's exactly right. And so these shapes, they do kind of look like a heart, if you will, where they have an indentation on one side and sort of a pointier end on the other side. Okay, so these do look like hearts. You can kind of think of them as a heart shape. So here's their equations, and we'll do the cosine one first, and then we'll do the sine one. So cosine cardioid, here's its equation, R equals A plus or minus A cosine theta. So you've got a little extra in there now, right? Like 3 plus or minus 3 cosine, or 4 minus 4 cosine, or 2 plus 2 cosine, okay? So what does all that stuff mean, right? So the description for a cosine cardioid is it's going to be a sideways heart. Why sideways? Because it has to be symmetric about the x-axis. So if it was a regular old heart, that would be symmetric going up and down. We want symmetry going sideways. So it's going to be a sideways heart, okay? So it kind of is going to look either like this or like that. Okay. And again, once I kind of show you the picture, it's going to make a lot more sense. What do the A's represent? Okay, so the A is going to represent, so I'll say 2A is the length of heart, and it's actually also the width. It's kind of hard to describe it. I'll show it to you better in the picture. And then what you want to know is this top one, it's always the pointy side that goes in the direction of your sign. So this would be a positive and this would be a negative. Because the positive one, the pointy end is going to the right, and with the negative one, notice the pointy end is going to the left. So let me show you what I mean. Let's do an example. Bless you. R equals, let's do 3 minus 3 cosine of theta. So for the cardioids, what you want to remember is these two numbers are always the same. Okay? Anytime you have the same number here, it's a cardioid. It's going to be a heart. Since it's a minus, I know the pointy end is going to go toward the left. This point on the inside of that heart is always at your pole. Okay, so since I said that 2A is the length, what is 2A in this case? Since A equals 3, obviously 2A is 6. So I'm going to go 6 out to get that point. So I go from the pole, and I count 1, 2, 3, 4, 5, 6. That's where the point of my heart is going to be. It's 2A. To get the other sides, again, I have to get a total of 2A to get out here. And so I'm going to do 3 up and 3 down. So I go up a distance of 3, and I go down a distance of 3. And then you literally just form your heart. It touches in at the pole, and then it curves around to your pointy end, curves back around through that point at 3, negative 3, and then back into the pole. And there's your cardioid. So stuff you just want to label is that this distance here is A, so is this, and that this length here is 2A. And it always has to touch at the pole. Okay? Since it's negative, it points to the left. If this were a plus, it would just go the other direction. Okay? It would just plane up to the right. Questions so far? Kind of cool. This one I'm going to show you on the calculator. So let me just show you how to graph them on a calculator so you can see it. It technically doesn't look as hardy as these ones do. It looks a lot more like kind of chubby. But let me just show you what it looks like so you can kind of get the feel for how to graph these on your calculator. In case you want to like ask somebody to turn about and like use a cardioid. Wouldn't that be like so cute? Could I have like a pre-calc romance? What do you guys think? No? I think it'd be adorable. If any guy asked me to turn to a dance using a cardioid, I think I might just, you know. Yeah, too bad my husband has no idea what it is. All right. So a couple of things. You got to go into mode, and you got to change it to polar now. So look, we were in parametric last week, right? So I want to switch that to polar mode. you can watch or you can follow along. Radian, in terms of degree or rating, it's got to be in radians. So it's got to be radians and polar. So now when I go to y equals, it automatically switches to r. Because notice all these equations are r equals, r equals, r equals, except for the line, which we can't graph on our calculator. Okay? So all these are r equals. So this one I want is this 3 minus 3 cosine theta. So 3 minus 3 cosine theta. Now there's one other thing I want to fix over here. If I arrow to the left, and see how it has that slash line? I want to change that because in parametric mode, in polar mode, I want to kind of see it being traced out. And so I hit enter to toggle through my different options. Well, mine does a little different. It depends on your calculator. If you just hit enter, 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 it should toggle through. I can switch here to the line. So I don't want that line. Oh, I don't want a dotted line. I keep arrow left, I guess. Arrow left or arrow right. I don't want a circle. I want that one. It's like a line and then a circle. That's the one I want. Okay. And then I say okay. So it's going to look like that on the left. It looks like this. It's got like a line and a circle. This is all in the notes in the front. Like that. Okay. Then I go to graph. Oh, actually, I should look at my window for a sec. Okay, my window looks pretty good. It was all over here. Window, theta should be at 0, and then 2 pi, which it is, a 0.1 step is fine. X min, this is telling me, I guess I could switch it. So I'll do negative 3 pi to 3 pi. That's fine for a scale. Y min, negative 2 pi to 2 pi. I'll do a 1. All right, that's just a nice trig scale. And now I can graph it. Right? Does it look like a heart? Not really. So it's kind of a chubby sideways heart. That's not really pointy, right? But yeah, it's still called a cardioid. The whole idea is it does have that dimple on the one side, right, and then the other one. No, it's not working. Don't use it then. Go to plan B. All right, so that's the calculator. Just kind of want to show you how you can graph them on there. All right, let's keep going. Oh, yeah. So you should, if you go here, depends on what kind of calculator you have. Yeah. Go here on the, to the left of R1 and hit enter, 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 and you should be able to toggle through options. Look at your options. Is it changing? No. Let me play with it. So actually, it's like they exit the house to solve. God, introvert stays inside. Wait, which one thinks it's half the game but that theta step makes a difference. Oh. All right, let's keep going. I got to get to Zima zones, and those take a little while. So, sine cardioid, same idea, you guys, except it's going to be a regular old heart. Up and down heart, right? So if it's a regular heart, since the pointy end is going down, this is your negative. When it's an upside down heart, the pointy end is going up, so that's your positive. And it's the same idea with the A's and the 2 A's. So let's do an example. R equals, why don't you guys do 2 plus 2 sine theta. 2 plus 2 sine theta. Got it? Okay. So A is 2, which means 2A is 4. Since it's positive, my pointy end is going to go up. So I do 1, 2, 3, 4. There's my pointy end. Always touches at the pole and then goes A out in either direction. And you draw your heart. Okay? So same idea. I've got A, and 2A. Easy? All right, let's do limaçons. Who takes French? Anyone take French class? Nobody takes French? This whole building? This whole classroom? Puro español. So this little C, it's like actually that little C with the thing underneath it. Did anyone ever take French? What's that called? I don't know. I don't take French. It's some weird symbol, C. Not weird. Different, right? That they use in the French language. And it's pronounced limaçon, like a son. I'm still not saying it right because I say it like it's Spanish, and it's not. Yeah, so do some sort of a French accent when you say it. So what are the limaçons? The limaçons actually have 3 different choices of what they are. So I'm going to kind of do a little sidebar over here for my limaçons. Notice the format of the limacons, as we would say them in English, right? Is it's A plus or minus B. So it's the same format as this one was, except that the 2 A and B are now different. Okay, so if they were the same, it was the cardioid. Now that they're different, though, it turns into a limaçon. Okay, so depending on your A and your B, right? So we've got a couple different options. If A is less than B, then you're going to get what's called an inner loop. Okay, so what your limaçon will look like, and I'll draw a cosine one, but the sine one would just go up and down instead of sideways, is that it's kind of like your cardioid, where it comes around, but then over here, instead of just dimpling in, it does this inner loop on the inside. Kind of cute, right? So that's your cosine limaçon. Again, if it were a sine one, it would be the same, but just up and down. Okay? What about if A is greater than B? There's actually 2 options, so I want to draw this a little differently. Let's go over here. Okay, so if A is bigger than B, and we've got 2 options here. If A is bigger than B and the ratio A over B is less than 2, we call this a dimple. So what will happen with this one is it's going to come around similarly, and it's going to dimple, but not at the pole. The pole is somewhere in here, so I'll draw a point for the pole. So it's going to dimple outside here, and I'll show you where to find where it dimples. Similarly, if the ratio A over B is greater than 2, then it's what we call flat or convex. And again, here's your pole. It comes around, and instead of dimpling here, it's just going to go flat across and then come around. It kind of looks like a guitar pick. I have a lot of people tell me that's a guitar pick. I don't know what else it looks like. When you graph it in a calculator, it's going to look like a big circle, to be honest. But it's a flat one. Again, and this point that I'm showing you is the pole here. All right, so let's see, where do A and B come into play on these examples, okay? So some people call these lima beans. They say they look like lima beans, and it's a limaçon, so they see the word lima, and they think these are lima beans. You can call it whatever you want. So we'll say it's a sideways lima bean. If it is plus, it's going to go, the pointy end again is going to go to the right. Pointy end is going right. When it's a minus, the pointy end goes left, just like it did for the cardioids. A plus B is the length from pole. A is still your width like it always was. And then A minus B is either going to give you your inner loop or it's going to give you your distance in the other direction. Again, when I show you the example, it makes so much more sense. So let's just go through the example. Ready? Let's graph. R equals, I'll do 1 minus 4 cosine theta. So notice A and B are different, so it's not a cardioid. I know it's going to be a limaçon. It's negative, so my pointy end is going to go to the left. So that's what I'm going to start with. A plus B is the length from the pole. So I'm going to go 1 plus 4. Ignore the minus for now. That gives me 5. That's the length from the pole to the pointy end. I'm going left because it's a minus. So I go 1, 2, 3, 4, 5. There's my pointy end. Okay. The width is always A. So up and down in this case is just going to be 1 and 1. Now I have to decide, is A less than B, bigger than B, or is that ratio bigger than B? Well, obviously in this case, this is my A, this is my B. So A is less than B, which means it's going to be an inner loop. So what's going to happen is it's going to come around, go through the pole, and then there's going to be some inner loop in here. How do I know how big the inner loop is? All I'm going to do is take that difference. So B minus A is always going to give you the inner loop. So 4 minus 1 gives me 1, 2, 3, and I loop-de-loop around, go back through the pole, back out to that 1 that was down there, and to my pointy end. And I am done. Kind of cool, huh? But again, all these little things you got to remember. So this down here was A plus B. This was B minus A. This was A. This was A. It had to go to the left because it was a negative. There's lots of little things to remember in practice. Okay? All right, we're on the last one, which is the sine limaçon. Similar, but it's going to be an up and down lima bean. Again, positive is going to go up, negative is going to go down. Let's do an example. All the other stuff is the same. So how about we do, I'm going to switch around the 1 and the 4. So let's do 4 minus 1 sine theta. All right, so there's my A, there's my B. A is obviously bigger than B. So as soon as I know that A is bigger than B, I have to do that ratio. So I just do A over B. In this case, it'd be 4 over 1. Is that bigger or less than 2? Bigger than 2, for sure. 4 is bigger than 2. So when it's bigger than 2, it is flat or convex. We use those words interchangeably. Convex is a little prettier. All right. It was a minus, which means the pointy end is going to go down. The pointy end is still A plus B. So I still am going to go down 5. 1, 2, 3, 4, 5. So this is still A plus B. It's just down because it was negative. My width is still A. 1, 2, 3, 4. 1, 2, 3, 4. There's A and A. Now, I'm going to come around. This is my pointy end. Now, over here is where I'm going to get that flat end. And I need to know how far from the pole is the flat end. Well, just like for the loop, we took the difference. We're going to do the exact same thing for this one. We're going to take that difference. So I'm going to do A minus B will give me where the flat end ends up. So in this case, it's 4 minus 1, which is 3. And so I go out 1, 2, 3. And that's where my flat end is going to come across. And what was this? I just said it. A minus B, right? So A plus B, A minus B, A, and A. A plus B, A, and then B minus A. If it were the dimple case, if this ratio were less than 2, it would dimple right here at that difference of A minus B still. So it would just come in and do a little mini dimple way up here, kind of like the cardio does. It would be a dimple up here, just not a dimple at the pole. And that's it. Information overload? Yeah, right? It's okay.
I have a question.
Yes.
Some in the cards,
Yes.
it